Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 60 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we are using the Sunfounder Raphael kit for Raspberry Pi. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I'm going to teach you today. And we have got a great lesson lined up for you today. Now, you know, in the last few lessons, in the last 5 or 6 lessons, we've become very familiar with OpenCV, and we're very comfortable in thinking about the frame that we grab from the Raspberry Pi camera as being a set of data. And we've been able to go in and look at that frame and find and track an object of interest. So far, our object of interest has been something that's a bright color, and we have been finding and tracking and all of that sort of stuff based on color. Well, that was just to introduce you to the concept, get you comfortable with the idea, comfortable of working with that frame. But today we're going to take things to a whole new level, because today, instead of just tracking something based on color, what we're going to do is we're going to grab that frame, we're going to analyze it, and we're going to see if we can find, box, and track a face. Pretty cool. I hope it sounds like fun to you. I am having a whole lot of fun with this stuff. Okay. OpenCV actually has some pretty sophisticated artificial intelligence features built in. And what I'm going to show you is I'm going to show you today how to begin to unlock some of those features. And OpenCV actually has some models of a face. So what we can do is we can go out, we can get the frame, and then we can analyze the frame looking to see if there is anything in it similar to a face. So there's some pre-trained models. Now what the challenge is to find those pre-trained models. And that's what we're going to show you today. So enough of this introductory talk. What I think I will have you do here is let's jump on over to the Raspberry Pi view. And what we want to do is we want to go ahead and start with that program. We want to start with that program that fires up the camera. So you can come to the most excellent www.toptechboy.com. Might be helpful if I got out of your way at this point. And then what we're going to do is we're going to come over here, and using the happy little search icon up here, you're going to search on something like calculating frames per second in OpenCV. And then you're going to come down here, and then you're going to grab this code by clicking on those 2 little pages. You can see it copied it. We're going to come back over to Thonny, and then we're going to paste that into Thonny. A couple of things I want to do. I want to come in here. I don't like calling this M. I like to call it frame. Wrong keyboard. I like to call that frame because we're grabbing a frame. So I'm going to come here. I'm going to call it frame. And then here, CV put text, we're going to put it on the frame. And then CV2 IM show, we're going to call that frame. Okay, little quick adjustment there. Now the other thing that you see is I've got this mounted on the pan tilt hat, and you guys, we've been playing with that in the last few lessons. If you're just jumping into this lesson and want to be able to actively track something, there is a link down below to this pan tilt hat. If you don't have the coin for the pan tilt hat, 90% of what I'm doing. You could probably kind of get by if you just got one of those little blue servos and taped or glued your servo to that. You would be able to at least do the parts of the lesson that are pan. Okay, the other thing is that when I put it on this, you can see that the camera's upside down, so I need to go ahead and compensate for that to flip it back around, and we can do that by just saying frame. You only do this if your camera's upside down. Frame is equal to CV2.flip. What do I want to flip? I want to flip the frame, and I want to do a -1 flip. And what that does is it rotates 180 degrees. Okay, sound good? Let's go ahead and run this thing and see if it works. Good, excellent. Look at that, almost 30 frames per second on a 1280 by 720 frame. So that is doing pretty darn good. Okay, now if we are going to go in and look for a face, we have to find that pre-trained face model, and that is called in OpenCV a Haar, H-A-A-R, a Haar Cascade. We need to find the Haar Cascade, or the model for the face. And believe me, if I tried to navigate down in the folders and you tried to follow me, it's very likely your folders could be named differently and you're going to get completely lost. So I'm going to show you a little pro way that you can find where your Haar Cascades are. So just follow along and it will work no matter where they are. So what I want you to do is, you see we are down here in the Python shell, so we can enter Python commands one at a time. I need you to say import OS for operating system. Now I want to find the path to the CV2 folder. So what I'm going to do is I'm going to say my path. So I'm just creating a variable path, and that is going to be equal to OS, the library that we just imported, dot, I want it to give me the path, dot, I want it to also give me the directory name, okay, of what? Of os.path.abs for absolute path, like that, and what? CV2 dot underscore file underscore 2 underscores on each side for a total of 4. Close the add path and then close the dir name and then hit enter. And now let's just put path, and boom, that has given me the path to the OpenCV folder for my system. You will get it for your system. And for example, you probably are not going to be PJM. You might be Pi here, you might be your username there. So now let's go see if we can find that. So what I am going to do is, let's open up our file explorer here, like this, and then you can see that we are already in /home/PJM, or you would be like /home/Pi or /home/Joe, but you're probably already there. So now what folder do we want to go to? We want to go to the .local folder. Uh-oh, no .local folder. I'm going to come back here to the icon view like that. You see no .local folder. So what do? Right mouse click, show hidden, and what do you see? Giddy up. You see your .local. You see your .local. Okay, so what I want to do is I want to go inside of .local. Next is what? Lib. So let's go inside of lib. Next is what? Python 3.9. And then site packages, right? And then CV2. So we are now in the CV2 folder. That's a huge amount of success. Now, where are these models? They are inside of data. So if we look, there are all of the models. Let me go back to the list view. So you can see there's like a Haar Cascade for the eye with eyeglasses, frontal face alt, full body. So there's all these different models of things you can find. Okay, we'll talk about that later, but let's go back up. What I want to do is I want to make it more easy to load one of those models, because if we did it right now, we would have to put in this very huge, long, difficult to type in path, and I want to put and then we'd forget how to do this next time. So I want to put these models somewhere that they're a little bit easier to point to and a little bit easier to find. So go up to data, right mouse click and copy. Okay. Now I need you to go to your Python folder, the folder that you use to store your Python programs. And so for me, let's see, I'm going to come back here and I am going to turn off. I don't like seeing the hidden files, so I'm going to come here. I'm going to right mouse click and I'm not going to show hidden anymore. Okay, because it kind of crowds things up. It's too much information. Okay, so now what I'm going to do is I copied that data folder. Inside of documents, I have a Python folder where I keep my programs, and then I am going to right mouse click. I am going to right mouse click and I am going to paste, and now I have that data folder. Why? When I run a Python program and then inside that program tell it to look for a file, it looks relative to the folder that you are in, the folder that program is in. That is what the starting point is. So if I put these models there, it's going to be a lot easier to find. So I'm going to rename this though. I'm going to come in and I'm going to rename it HAAR, because if we come back in a month, right, we're going to, what was that? Oh, it's already there. So I'm sorry. I'd done this before, and so it was already there. Okay, but when you do it now, you should have this folder called Haar, and if we look in there, there are all of our different models. Okay, so now we know where they are. They are inside of my default Python folder, and then it's inside of a folder called Haar. So we'll need to remember that. Now we're going to come over here and we're going to see if we can start doing a little artificial intelligence and a little bit of face finding. And so the first thing that we want to do is I think a good thing would be to come here, and before we go in this while loop, this is where we are going to start doing our magic. Okay, so the first thing I need to do is I need to create an object for my model. So I'm going to call my model face. I'm going to call it face cascade, like that. And what is that going to be equal to? It's going to be equal to cv2.cascade classifier, uppercase C cascade, uppercase C classifier. Now I have to point it to the model. So I open a string. First of all, I'm going to put a dot. That dot means start in my current working folder. That's the folder where this program is saved, right? That's my Python folder. So I'm starting at dot, my Python folder. Then I need to go down to which folder? Haar. And then I need to put the name of the file. So let's look at these, and you see all of these different models. The one I want to use is this Haar Cascade _ frontal _ default.xml. Okay, so let's see if we can put that in. HAAR CASCADE Haar Cascade _ frontal face _ default.xml, close the string, and then close the classifier like that. Okay, so we have that done now. So I've created my model. I've created an object for my face model. Now we need to use it. Okay, now what you got to see is this is becoming very computationally intense. And when I have a big 1280 by 720 frame, that is a huge file, and it's even huger. It's huger because it is color. And so it's, what I want to do is I want to make it a little smaller so my program will run a little bit faster. And so what I'm going to do here, after I grab my frame, I'm going to create a new frame gray, like that. Okay, I'm going to create a new frame gray. And that is going to be equal to cv2.cvt color, like that. I'm going to convert the color. And what do I want to convert the color of? Frame. And then how do I want to do it? cv2.color, cv2.color. And what do I want to do? I want to go from BGR to gray. Okay, because a grayscale image will be a lot smaller, and therefore our program can run a lot faster. I think I better do it after. I think I better do it after the flip. So just to make sure things don't get confused, I'm going to do it after the flip. Like that. I think that would be smaller. All right, now I'm going to go in and I'm going to see if I can find faces. All right, so what I'm going to do is faces is equal to face cascade. That is the object that I created, right? And then I want to do a dot detect multi-scale. Okay, detect multi-scale. What do I want to look at? I want to look at my frame gray because it's going to go a lot faster if I do that. Now I have to give it a couple of parameters, and I'm not going to talk about these parameters very much. You can play around with them and you can study them, but I don't want to spend an hour talking about them. The first number is the scale factor, and that's just saying as you're looking for faces, if there's multiple people, there might be a person closer and a person further away, and their face might not be the same size. And so we kind of got to give it a range of scale factors, and 1.3 works pretty well. And then the next thing is kind of like how many nearest neighbors need to find a face before you call it a face. So like if this sees a face and this sees a face and this sees a face, you know, as the rectangle is moving around, how many times do you need to see it in nearest neighbors before you call it a face? And 5 works pretty well. You can play around with not specifying the parameters using default ones. Play around with it, study it, but I'm just trying to get us where we're finding faces now. So I'm not going to talk really any more about that. Okay, so now what we should have is we should have this data structure called faces. And that data structure called faces, should return us data if it finds a face. And so what I'm going to do is, let's just sort of see what happened. I'm going to try to point this at myself a little bit more. And what I'm going to do is just print faces like that. So we'll see what we get back. All right. And so I'm going to come in here and I'm going to run this thing. Hold your breath. It ran. Okay, now look at this. We are getting data. So I hope if I quit this, that doesn't disappear. My data doesn't disappear. Okay, good. It didn't. What do we see? We see an array inside of an array. Okay, and we see 4 numbers. Now let me kind of draw this out because it's really important that we understand this. Why didn't it just give me the 4 numbers? Why did it give me an array inside of an array? Okay, that is because I'll just kind of draw up this data structure for you. Okay, the inside array is it found a face. Okay, it found a face. And then what it is giving me is it is giving me the X, Y coordinate of the upper left corner of the bounding box of the face. And then it is giving me the width of the bounding box, and it is giving me the height of the bounding box. And so what it is giving you here is X, comma, Y, comma, W, comma, height, like that. All right. But it is giving it to you inside of another array. Why? What if you found 3 faces? Well, this would be face 1, and then it would have those again for face 2, comma, those again for face 3. And then it puts all of those in an array. So what would I have? Faces of 0 would be that first face, X, Y, W, H, like that. And then faces of 1 would be the next one. Okay, but what does that mean? That means even if I have one face, I can't just go in and say faces, right? I have to index faces. Even if there's only one face, I've got to refer to then what? Faces index 0. Okay, hopefully that makes sense, but your life really will be easier if you understand these data structures. So here we are. So what was the 618? That was the X position of the upper left corner of the box that would go around my face. 98 would be the Y value. 286 was the width, and 286 was the height. Well, if we have all of that, what would be a pretty cool thing for us to do now? What would be a pretty cool thing for us to do now? Draw a box around it. Okay. Now the way I'm going to handle the array in an array, I'm going to say faces is the group of arrays of the individual face singulars. Okay. So what I'm going to do is I'm going to say for face in faces, face singular in faces plural. So if there's 5 faces, it'll step through all faces. If there is only one face, it'll just go to that one face. But for face in faces, now what am I going to do? I'm going to say X, comma, Y, comma, W, comma, H is equal to that individual face. So it's going to take that array. The first element's going to go in X, the second element's going to go in Y, the third element in W, and the fourth element in H. So now I have what I need to do a what? CV2.rectangle. Okay, CV2.rectangle. I want to put the rectangle on what? On the frame, back on the original frame. Okay, and then what's the upper left corner? It is the tuple X, comma, Y. Close the tuple. What's the bottom right corner? It would be X plus W and H plus comma Y plus H. Okay, then let's give it a color. I think I'll go with a blue box today. What do you think? 255, 0, 0. And then how heavy do I want that box? Let's make it a 3. And then I'll go like that. Could it really be that easy? Now, the cool thing is if there are no faces, it won't even go into this. So we don't have to worry about the program crashing if it doesn't find anything. Okay. I will really need you to hold your breath this time. Look at that. Boom. I'm human. Do you realize how heartwarming it is that OpenCV recognizes me as a person, that I am not so obscure that it doesn't recognize me as a human being? Look at that. Okay. One thing is I want you to notice is look at that. It found it and it is tracking me. It's alive. It is working. What do I also want you to see? What I also want you to see is we have taken a big hit and we've gone from almost 30 frames per second to 6 frames per second because we are really doing a lot of computation. We are really doing a lot of computation. What if we came here and we went 640 by 360 like that? Okay, so you see now I've gotten my frames per second back up higher. Okay, I've gotten my frames per second back up higher. All right, so that is that is what is needed. And I'm going to go back. I'm going to go back to 1280. Was that right? Where was I? Yeah, 1280 by 720. I thought that was right. Okay. There I am, and we are getting about 6 frames per second. Okay. Now, guys, this is what your homework assignment is going to be. Your homework assignment is going to be, and give me just a second here. I need to take a look at this and make sure that I am telling you right. Okay, this is what your homework assignment is. Your homework assignment is, I showed you how to find and box a face. What your homework assignment is to go in and find and box not only the face, but also find and box the eyes. Okay, find and box the eyes. Now, I did, to get the eyes to work good, I will give you a hint. I use the Haar Cascade _I. Okay, and then also I played around with those parameters and the scale factor. Remember when you do the detect multiscale, I did a scale factor of about 2.25, and then I did the number of nearest rectangles at 25. Now you can play around with those, but just don't think that if you don't use any parameters at all there when you do your detect multiscale that it's going to find the eyes good. You'll have to play around with those a little bit. But what your homework assignment is to go in, find the face, box the face, find the eyes, box the eyes, and then report your frames per second. Report your frames per second. Make a video, put it on YouTube, show that you're finding the face, you're finding the eyes, and show your frames per second. Because you can see what we're starting to do. We're starting to really tax our CPU on the Raspberry Pi. We're not getting 30 frames per second. We're getting down to a few frames per second, and there's still a lot more work that we want to do. And so we are really starting to squeeze the processing capability of the Raspberry Pi. Okay, guys, I hope that you are having as much fun taking these lessons as I am making them. I am just really excited about where we're going here. Let's see, my camera is a little bit off there. It should pop back here in a second. There it is. Okay. Let's see how island people are doing. We haven't checked in on them in a while. You want to check in and see how they're doing? Let's see. It looks like the boat is departing, huh? The boat is departing. I just love watching my friends. These people are my friends and they're my neighbors and they're out getting their work done. Let's see. Lady is probably planting her garden up there. You can see the banana trees are looking good. Okay, I got digressed. I got sidetracked there. So what is your homework? Your homework is to find the face, find the eyes, report it on YouTube, and show your frames per second. And don't cheat by going down to really little things. Do the 1280 by 720, and let's see who can get at 1280 by 720. Let's see who can get the highest frames per second. Guys, I hope you are having as much fun taking these lessons as I am making them. If you enjoyed the video, give us a thumbs up. If you haven't already, subscribe to the channel. When you subscribe to the channel, make sure that you ring that bell so you'll get notification of future video drops. And as always, share this video with other people because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.